So we'll start chapter 14. I don't want to review 13 because we did review and some problems also last time, right? So I don't want to, without further ado, let me start something called simple harmonic motion. Alright. Simple harmonic motion is what? Waves? Not yet waves. Simple harmonic motion is a motion to and fro motion. Right?
What?
To and fro. With front and back. So let's do this. Remember I gave you one problem in your exam about there was a spring attached and there was a iron block
Yes.
on a frictionless table. And what happens is if you, let's say if you apply some force, there will be a displacement, let me call this 0. Right? So your origin is here. If you apply, I call it force applied, okay? FA.
Okay.
Alright? If I apply force, more will be the displacement, right? Isn't it? More force, more will be the displacement. Actually, the displacement X is proportional to the force. Isn't it? We did last time. So applied force is kind of proportional to displacement, right? Isn't it? When I pull it, my applied force, when I apply a certain force, the spring will apply force against my force. That force is called restoring force, okay? So whatever is my force, the spring applied back, I use my rating. This is called a restoring force. Alright? Restoring force is force applied by the spring. So if I really plot a graph, what happens is, if I plot a graph, my applied force, FA, if I apply like one force, my to make a displacement 1, I have to apply like one force, certain. If I want to double the displacement, I have to double the force, isn't it? Yeah, basically it goes something like this, right? If my x is this side, and similarly, if I go on the opposite side, means from here, if I want to go the displacement on this side, my force has to go this side, isn't it? Right? So, if my force is negative, my displacement will be negative, right? So basically my line graph will be something, well, it looks weird, right? It should be straight line anyway. Alright? This is the applied force versus the displacement. But if you think of the force applied by the spring, which is just the opposite. So if I displace this way, the spring will pull this way. Magnitude will be same as my force, isn't it? But if you plot a graph of restoring force, then what it becomes is, oops, why is ink coloring? So my restoring force versus, this is I call restoring force, alright? F versus X will be the other way, right? If my force, if my displacement is on positive, my force will be negative, right? If I double the distance, my force has to be doubled. The spring force will be doubled. So basically, the restoring force versus X will be, X versus force will be something like this. This one is restoring force. Alright?
So
yes.
restoring force would be
the spring force.
The force opposite to what you're
Applied.
You're applying.
Yes. The restoring force is the force applied by the spring. Alright? So now, when there is a simple harmonic motion, it's not about my force, it's about the spring force. That's pull it back and goes further back and then pull it back again. Now when it is this side, now the spring force will be this side. Right? So it pulls back again and keeps on bouncing front and back. So now this equation, if I write here F, it is proportional to X. Now this will be F equals to something called negative, because this will be on the opposite direction of X. And this guy is called what?
The spring constant.
Spring constant, very good. SPRI, spring constant, also called force constant. Alright? Also called force constant. Now this is actually the Hooke's law. Right? Hooke's law, the restoring force is directly proportional to the displacement. So now if I try to convert, let's say this block has mass m. If the block has mass m, then my force is basically mass times acceleration. Is that right? So this will be equal to minus k of x. So if I want my, well, a is on the direction of x, by the way, right?
Yeah.
Because the force direction is along x, so I can write here fx. Alright? So my acceleration will always be negative of k over m of x. So far. Right? So this I stop here for now. Well, by the way, acceleration can also be written as d square x by dt square, isn't it? Minus q over m x. I'll go back and discuss a little bit about time period, which is the spring goes front and back, right? Right? And then discuss something about frequency, time period, and something called angular frequency, alright, which is angular velocity. Remember last time we discussed about angular velocity, right? What was the angular velocity? Omega.
Omega.
What is it?
Oh, Richard.
B over R.
Well, yeah, but yeah, let's not do that for now. In case of frequency, what is frequency, by the way?
That time, one of it.
Oscillations per second.
Oscillation per second, right?
Yeah.
It's oscillation, OSCILLATI, oscillation per second, right? What is omega? Omega is
2 pi.
angle per second,
Yeah.
isn't it? So angle per second. So in in 1 second, if there are f frequency, f number of oscillation, right? Then what will be your omega? Oscillation means what is the angle?
2 pi per second.
2 pi per second, isn't it? Right? So basically omega is 2 pi of f. Very follow? Because one f has 2 pi angle, isn't it? One f has 2 pi angle in it.
So yeah, the frequency is cycle.
Right, frequency is cycle per second,
Right.
right? So your angle per second will be, one cycle is 2 pi angle, right?
Because one cycle is
So, right,
Yeah.
right. So yeah, good, exactly.
Yeah.
This, right?
Yeah.
One
They
cycle.
actually.
So this is like 1 per s, which is like hertz. S per second is the unit is hertz, right? Hertz is the unit for the oscillation, and 2 pi f. And what is the time period? What is the time period?
Time is not one.
Right, time to
One
take
over
one
2 pi
round.
f.
So 1 by f.
One over frequency.
Because this is oscillation per second. So to make one oscillation, it takes 1 over f second. Right? So this is the time period which is in second. Alright? These are a few things. By the way, in case of oscillation, it moves from here to there, right, and comes back again to the original position. That's called one time period. This goes here and comes back to the same position. That's what we call time period. And the frequency is in 1 second. How many oscillation means front and back? How many those time period will be there? You have a piston here. All right, you have piston here, and the piston is connected to a wheel. This is a wheel. All right. So now let me make another ink. Let's say red one. All right. If the piston is here, if the piston moves here, this goes somewhere here. All right. This rod push here, right? Right. And when the piston is here, let me use another ink. This is black. And if the piston moves up to here, then the rod goes up to here. Okay? So this is like, here it is here, and it's pushing, it's going here, and it's pushing further, it goes here. Now from here it comes back. When it comes back, now it goes back to the red position. Are you following? So this will be here, turning back, right? and then when it is here, it goes back to this position. Are you following? So this is how the even car pistons, all those engine usually work. There's a piston there, there's a cylinder, right? There's a piston which moves like front and back, and that's connected with a circular thing. And actually it's moving front and back, here it goes like round and round. Grand mass, the old fashioned sewing machine, yes. The sewing machine, if you press the pedal like up and down, you are only pushing up and down, isn't it? But here it rotates, right? So because there's a rod connected, isn't it?
Yeah.
Right? And then, right, it moves up and down, and then here it goes like round and down, isn't it? This round is a circular motion. The up and down is a simple harmonic motion. Just like this, it goes front and back, but here is a circular motion.
If you're looking at it, you're not
Right?
even
So basically, the point here is I'm giving this example just to explain you that the simple harmonic motion can be represented by the projection of uniform circular motion on a straight line. This is a circular motion and this is a straight line. This one is simple harmonic motion, this is the circular motion. Alright? So in other words, I'll leave this for now, I'll erase this one and draw a circular motion and then the projection. This is my circular motion. Oops, it looks like circular? Yeah, pretty much. Right? And this one is, excuse me. This one, let's Bob start here. So projection means what? You have a flashlight here, isn't it? Light is coming here, and you have a certain ball rotating in a circular orbit, and this is your projection. So when the ball is here, right? The shadow will be there, right? And if the ball goes here, the shadow goes here, right? If the ball is here, the shadow goes here. Is that right? And if the ball goes back, the shadow, right? And then the shadow keeps going. So what happens? If it rotates like in a circular orbit, this shadow goes like front and back. So this shadow, motion of this shadow is a simple harmonic motion. Alright? So this is your origin 0. This is your x. Alright? And by the way, I forgot to explain one more thing. Omega f, and there is something called amplitude. Alright?
Amplitude is like up and down.
Yeah, amplitude is the maximum displacement, which is basically the radius. Isn't it? The maximum displacement is what? From here to there, right? Isn't it? Maximum displacement can be on the positive side as well as the negative side. Plus A, this maximum amplitude is, maximum displacement is called amplitude. So basically your A from here to here will be A or minus A. That's where it goes. Right? But that corresponds to, in case of circular motion, that corresponds to your radius. Right? So let's say if the ball is somewhere here, your angle is theta. Right? If the ball is there, an angle is theta. Then your displacement is from here to here only, your x. Right? Because x is what? This is your x. Isn't it? So your x is given by what? What is your x? It's given by what? In terms of, let's say this one is your A.
It's given by cosine theta.
Cosine theta, very good. So your x is given by A of cosine theta. Is that right? Is that right? X is given by A cosine theta. If I want velocity, what do I do? You do the derivative, right? So if I do dx by dt, it's what? A minus, right? Minus sine theta times d theta by dt. Isn't it?
Yeah.
What is this guy?
This is W.
Omega, right?
Yeah.
Not W. Right? So this one is omega. So in other words, it is minus A omega sine theta, isn't it? Right? A omega sine theta. In case of theta, I can write omega times t. Is that right? Because my omega is what? Theta over t. Right? Because it's called uniform. Because my motion is uniform. uniform. When I say uniform, it means there is no acceleration. Alright? When there is no acceleration, it means my omega is constant. Right? So when I say constant, I don't need to put like derivative here. Simply theta by t will be okay. So what it means is my angle is, my theta is basically omega times t. So this theta is omega times t will be my theta. So I can simply, actually I could have done this like x equals to a cosine omega t rather than writing theta. So if you do the derivative, this will be dx by dt, omega comes front, minus a omega sine of omega t, right? Isn't it? Which is basically same. Alright? So now, if I need the acceleration, what is it? D square x by dt squared, which is what? Minus, I have to do the derivative again. Is that right? So if I do the derivative again, it becomes what? A omega square, right? Right? Because 1 omega will come again. The sine, derivative of sine will be cosine. Cosine of omega t. This coefficient comes here, it becomes a square. Now look at the interesting thing here. A cosine omega t. A cosine omega t is what? Again x. A cosine omega t is x. Isn't it? So now A cosine omega t is x. So I can write here d square x by dt square, which is basically A along x. Isn't it? This is nothing but minus omega square. This and this will make it x. Right?
Yes.
Beautiful. Now look at that. What we got here is ax somewhere here. Oops, this one is ax. Ax we got it this. That's why I didn't erase this one. Right? So when I ax equals to this, and now I got ax equals to this, what it means? You have minus minus. So this guy omega square is what? K over m. Is that right? Because if ax equals to minus k over mx, and same ax equals to minus omega square x. So from this equation, a, and on this equation, let's say b, right? What you get here is omega square equals to k over m. Is that right? Is that right? So what it means is omega equals to square root of k over n. So if you know the mass and if you know the spring constant, then you can find omega. Not only omega, you can also find the time period, right? What is time period? T. So 2 pi over omega. Over omega will be square root n by k. If you want to plot a graph, let's say, if you want to plot a graph, what happens? What happens? In this particular case, where is it? What will be the displacement of this one? Like cosine theta is, let's say, omega t here. Alright? If you have omega t, let's say you have t on this side. Or basically theta on this side. Because theta has t. Your omega is constant.
Professor, isn't it t 2 pi times omega?
T equals to?
T, the time, equals 2 pi times omega, right?
2 pi.
Or 2 pi over omega.
2 pi over omega. 2 pi over omega.
That's why you put it m over k.
Right.
Because, okay.
Yeah, denominator.
Yeah.
So basically all you need to remember is omega is 2 pi, f is frequency, right? Cycle per second, one cycle has 2 pi angle. So total angle will be 2 pi times f will be total angle per second. So this will be your omega. But f is what? 1 over t. So 2 pi by t. So when you do like cross multiplication, this actually t will be 2 pi by omega. Pi will be here, omega goes down. If I wanna plot this at time 0, what will be my displacement? Will be a, right? Isn't it? At time 0, omega t is like t0, right?
Yeah.
At time 0, it will be what?
1,
Maximum a, right? Okay, a, it will be here. At theta equals to pi over 2. Theta equals to pi over 2, it will be 0. this your theta equals to pi over 2. Basically theta is your t is, well, omega times t is theta, right? So if theta is pi over 2, then t is basically what? This is pi by 2 omega, right? Pi by 2 omega or something. So anyway, at that point it will be 0, right? Because pi over 2 cosine will be 0. So it goes like this. Very good. By the way, the time period is what? From here to there will be time period, right? This will be your time period. Or basically from here to here will be time period.
Yeah.
Is that right?
It should be the same.
If you increase the amplitude more, what happens? Let's say your amplitude is more.
Go ahead.
Forcefully put your amplitude.
Yeah.
Time period doesn't depend on amplitude. Does it depend on amplitude?
Okay.
Is there A here in place of time period?
So it's going to be what?
Is there A here?
Yes.
No. Right? So if you increase the time period, if you increase this, in a spring, if you, let's say, pull more amplitude for the same spring, for the same mass,
So this equal
and for the same K, your amplitude will be more, your amplitude will be more, but your time period will not change. Because this does not have, it is not amplitude dependent, right? So basically, if you have different amplitude, let's say you have, this is your A1, and if you have A2 or different amplitude, A2 from here to there, then this will go here, because time period will not change, so this will increase up to minus A, right? But it goes here. If you make it smaller, then what happens? You make it smaller, then it doesn't change. For another one, the time period still remains same. Plot what happens if you increase the amplitude, and what happens if you increase the K, and what happens if you increase the N. If you increase K, if you increase mass, your time period will increase. Alright? In this case, if you increase mass, your time period will increase, but if you increase K, your time period will decrease. Alright? So in other words, I don't want to mess up the whole graph, but basically, if your graph is like this, if you will increase your mass, your time period increases. So basically what happens is, it will be from here, it will be little like this. The graph will be something like this. So the time period will increase. Right? But if you increase K, if you take a different spring with another K, right? Another strong K, then it happens something like this. Alright? Make sense? So from here, the time for this one, the time period is from here to there. This is the time period, right? For the red one. For the green one, this is the time period. Look, the time period increased, right? For the black one, the time period is shorter. Right? So if you increase, what happens? If you increase K, time period will go down. If you increase M, time period goes up. But if you increase amplitude, time period remains same. Time period doesn't change. Only the amplitude changes, but the time period doesn't change. We had the circular motion. Right? We had the circular motion where we started from this point, right? Isn't it? We started at maximum displacement. But this is not always true. How about if the body starts from here? At time t0, you are here. At an angle, let's say phi. Now the question will be, your x will be what? A, well, of course this is your A. A is from here to there. A is the radius, or in other words, maximum amplitude. Isn't it? radius A, but your cosine of, instead of omega t, let's say it goes from here to here, wherever. Now the angle will be this, theta will be omega t. So actually your angle will be omega t plus phi. This phi is called phase angle. Okay? This phi is called phase angle. Now if I want to find what? I want to find velocity, acceleration, and what else? Amplitude. Alright? How will you calculate it? Start with this expression. And then see. Say it again. Do the same thing. We already did anyway, but let me do it in more generalized form, where not a specific that started from t equals to 0 at x at the maximum amplitude point, but somewhere there in the middle. All right, where you have a phi phase angle there already. That's also called phase difference. So do the same thing. Your v equals to what? Your v equals to dx by dt, which is what? A minus a omega sine of omega t plus phi, right? And your acceleration is what? Acceleration is, what is it? D square x by dt square, which is minus a omega square cosine omega t plus phi. Right? So now here's the trick. If I wanna find in terms of x, right? Now what happens here is the following. You can replace this sine omega t, a sine omega t, with your expression what? Your expression is this. From here, you get your cosine of omega t plus phi is what? X over a. Here is cosine omega t plus phi. You replace this. This is easy. Your acceleration ax equals to, this one is pretty simple, minus a and cosine omega t you can replace by x, so this will be minus omega square x. That's pretty simple. Or cosine omega t put x over a will cancel, it will be the same thing. Minus omega a, well, a omega sine of omega t will be what? Square root of 1 minus cosine square omega t plus phi. Is that right? Because sine square theta plus cosine square theta will be 1. Right? Do you know this expression? Sine square theta plus cosine square whatever equals to 1. Right? So what it means, I'm trying to convert, because I know cosine of this is this much. If I know cosine of this is this much, so how do I convert this sine into cosine? Is just use this, right? Did you get an idea?
Wait, no.
No?
I got lost.
You know this thing.
Yeah.
Okay. Can you write down sine theta equals to 1 and then cosine theta goes right? Cosine square theta, but sine is square. So if you replace the square, it will be square root.
Oh, okay.
Right? Now I can replace this guy with this.
Okay.
Is that right?
X square by x square.
Yes. So now what happens is my Vx will be minus omega a, and then this guy will be 1 minus cosine square will be this x square over a square.
Okay.
Having fun now? Right? Look here. Now look at the beauty here. If you simplify this word, minus omega a, this will be, you can take factor a out, right? A square, minus x square divided by a square with a square root. Is that right?
So
This a square comes out and cancel, right? So this will be minus omega and then a square minus x square.
A minus x.
What's that?
Mm.
That's it. A will cancel. This is
Okay.
inside,
Oh.
comes outside with a single A, and that will cancel with up. So you have only this. So look at the beauty here. Look at the beauty here. In the simple harmonic motion, again, back to the same story. You have a block. It moves from here to there. Here's your origin. It moves from here to there. I'm not using the spring and all those things. Okay. So this goes bouncing front and back with your amplitude. With your amplitude A. Right? This one is minus A, isn't it? Right? Now look at the beauty here. Look at the beauty here. What will be the, listen here, the question. What will be the velocity at the extreme point? What will be velocity here? Zero, right? Because at this point, your x equals to A, isn't it? This is your x equals to 0. And your x keep on increasing where? Up to maximum is A, isn't it? So when your x equals to A, at the extreme point, A square minus A square, this is 0. Right? So at the extreme point, your velocity is 0. Same thing at minus A also what? Minus A square will be plus A square, right? So A square minus A square will be 0 again. So at those points, your velocity will be 0, both extreme point. Is that the beauty? Right? So what about at x equals to 0? What will be the velocity at x equals to 0? What will be the velocity at x equals to 0? At x equals to 0,
Negative omega.
what will be the velocity?
Negative omega.
Negative
A.
Of x.
Omega
A.
A. That's it,
Yeah, because A is a square.
isn't it?
Oh, yeah.
Right?
Yeah.
Look at the beauty here.
Okay.
Remember, the velocity was omega r. The angular velocity was, the linear velocity was angular velocity times r. A is r.
Okay.
Actually, there will be a little bit of sign convention also. It will be plus and minus. Alright? Whether it's coming from this way or that way. Alright? Because it has to be plus or minus. So basically it will be plus or minus. Alright? This one will be plus or minus. That leads to plus and minus here. Alright? And this leads to plus and minus here. And so on. Okay? So in case of whatever is the x, your acceleration will be this. And your velocity will be this, with plus and minus anyway. Alright? Okay, how will you calculate phase?
How do we calculate what?
Phase. Like the angle phi. At t equals to 0. At t equals to 0, what happens to your velocity? What happens to your x? X 0, let's say. At t equals to 0, I call it x 0. Alright? Which is what? A cosine what? Phi. Right? Now, I come here, velocity. At t equals to 0, I call my velocity at x 0. Alright. Okay, velocity here at 0 will be what? Minus A omega sine phi. Is that right? Is that right? So if I want phase, it's very simple. How will I calculate phase? Or how will I calculate amplitude? First let's calculate phase. Alright? Then we'll go with the amplitude. Alright? So in order to calculate phase, what you do is you divide this by this, right? Isn't it? Right? So when you divide this, what happens? Let me use another pen, or I can just do this. I just divide here a cosine phi, I divide here by x0, right? So this a will cancel, so this will be what? Tangent of phi. So tangent of phi will be Vx0 divided by omega x0. Is that right? With a negative sign. Right? So in other words, the phase angle phi can be defined as arctan of minus Vx0 divided by omega x0. How will you get the amplitude? How will you get amplitude? How will you get amplitude? Is square, square. Use the same identity, same this one. Alright, sin square theta and cosine square theta will give 1. So square this, make it cosine square, square make it sine square, and add them, isn't it? And you left with a. Did you get that? In other words, okay, let me do it slowly. So cosine square phi will be x0 square over a, right? Is that right? Sine square phi will be Vx0 divided by a omega, isn't it? So sine square phi equals to Vx0 square divided by what? Omega square a square. Is that right? Because minus will, well, when you square it, the minus will go away anyway. It will be minus this by this, but when you square it, that minus will be plus. So now what you do is this square plus this square equals to 1. In other words, x0 square by a square plus Vx0 square by omega square a square will be 1. Take factor 1 over a square outside.
It's going to be x0.
So this will be x0 square plus Vx0 square divided by omega square. Is that right? Equals 1. So this goes on the right, it will be a. So a will be square root of x0 square plus Vx0 square by omega square. This is the expression for the amplitude. If what are given? If the velocity and the displacement at time t equals to 0 is given. Okay. All right. What is the energy of, by the way, last time I gave you one question, right? When your course was something and find the kinetic energy at a certain displacement, right? Do you remember that? It's pretty much similar. How will you calculate, let's say you have a simple harmonic motion. Again, I'm not drawing this, okay? This guy moves, this is the origin, it moves front and back. Alright? On the x-axis. Right? On the x-axis. So let this one is A. A is the maximum amplitude. Right? At a distance small, let's say x. This is at point x. Alright? This guy, at this point you have both potential and kinetic energy, isn't it? Right? What will be your total, what will be your K at this point? K is what? 1/2 mv square, right? V at x. Isn't it? Velocity at x. I write here Vx. Alright? Velocity at x. By the way, velocity at x, there are two velocities. One is plus, another one is minus, but it doesn't matter. Because if it's going from this way, it is plus. If it's coming back this way, at the same point it can have two velocities. Right? Plus and minus. Well, we derived there somewhere earlier, isn't it? Velocity can be plus and minus. At the same point it can have plus or minus. Now Now what happens here? Now what happens here? This is your kinetic energy. What is your potential energy? We usually call it U elastic, right? What is the potential energy at this point? X. What is it?
Net zero.
What? What's the potential energy?
Minus.
What is the elastic potential energy of a spring if it moves
Negative
a
kx
displacement?
squared.
Say it again.
Negative kx squared.
Negative?
Kx squared. 1/2 kx squared.
1/2 kx squared. Yes.
Oh.
You just did and then you forgot.
No.
You just did in your second
No.
exam, right?
I remember.
So what is your total energy? E. K plus U. What is it? 1/2 n Vx square plus 1/2 kx square. By the way, I can plug this half, but thing is I cannot add these two, isn't it? I cannot add apple and orange,
No,
isn't
but
it?
you can say.
I have to convert it, isn't it? So what is the formula for the velocity? I removed it, right?
W.
What is the formula for the velocity
is
in
omega.
terms of omega? Okay,
Omega
which is
times
1/2 and this was what?
Omega times every.
Omega times
Square root of
square root of
a square minus x.
a square minus
X.
x square, but now you have a whole square, right?
Yeah.
So Vx is this, right?
Like I asked,
I'm trying to convert into x, so now okay, I'll leave it this plus 1/2 of k x square, isn't it? Now what I'm trying to do is here is again okay, x square is okay. Now what I have is 1/2 of n omega square, and this will be a square minus 1/2 of n omega square, 1/2 of n omega square x square, right? Is that right? Right? Now, what's wrong? Something wrong here. Now, still I cannot add. Still there are apple and oranges. Now, banana also included there.
Yeah.
Apple, orange and banana. Isn't it? So now the problem is, oh, here I don't need to worry because this is constant already. Now, what is the relation between n, omega and k? I'm trying to convert it to k. So, what is the formula for omega? Square root of? Square root of? K over m. Very good. Right? So, what it means is omega square is k over m. This implies m omega square is k. Is that right? So in place of m omega square, I can write k. So this will be what? 1/2 k a square minus 1/2 k x square plus 1/2 k x square. Oh, look at the cool thing. So this gone, right? Plus and minus. So I'm left with, so your total energy is 1/2 of k a square. So basically total energy of a simple harmonic motion is equal to the potential, elastic potential energy at the extreme point. A is what? At the extreme point. If you plot a graph from, let's say, A to minus A, in case of a spring here, the potential energy here will be what? U elastic will be 1/2 k a square because your x equals to a here, right? Is that right? Now, at this point, your potential energy, well, by the way, what is your kinetic energy here? What? 0.
0 with v.
Right? Why is 0? Because the velocity is 0. Isn't it? So your total energy will be this guy. But when it is at this point, your u is 0, right?
Yes.
Because your displacement is 0. So kx square, right? This guy is 0 here. But the potential energy, if you convert this Vx square at the center point where this x is 0, right? Right? Or in other words, let me do here. Let me do it here with a another ink. At this point, my kinetic energy, my K is what? 1/2 m v square. The formula for v square is omega, this guy, right? Omega square, and then a square minus x square, but x is 0. Isn't it? So what it means is it will be again m omega square is k. Right? So it will be same as k a square. It will be same as what it was at the extreme point. Make sense? So at the center, your kinetic energy basically equals to the potential energy what it was at the extreme point. So if I plot a graph at the center, let me draw the kinetic energy. Kinetic energy at the center will be maximum, right? But at the end, at A, it will be 0. Oops. At A and minus A. Well, this is your A and minus A, right? But your potential energy will be maximum at, and it goes parabolic because it's square, right? It goes square. So that's why I don't want to, it doesn't go the straight line, but it will be a parabola. So what is the red pen? Okay. You can draw it green. So at extreme point, your potential energy will be maximum, but it will be 0 at the center, and then it will be maximum again, it will be parallel. Okay? So the total energy is constant. So this red is total energy. Alright? This green is, what is this green? Potential energy. Elastic potential energy, okay? Elastic potential energy. And this one is what? This green is the blue. Blue is the kinetic energy. This one is the alright? So when you see at this point, your kinetic and potential energy is same. Now question, at what distance, do it yourself, homework. Right? At what distance the kinetic and potential energy is equal. Find x where your k is equal to k equals to u. Alright? So the question here is k equals to u. Now you need to find x. Alright? What will you do? In case of k, you write down this. Right? You write down this, but make sure you have a square and an x square will also be there. Right? Will it be halfway? The kinetic energy, look, every place what happens is your kinetic energy will be this much, right? And at this point, your potential energy is this much. So this plus this was here. So this plus this will be this much. So it goes down this much, but it increases by similar. So this portion will be here. So this guy plus this guy will give you this guy. So every time when you add those two curves, this is going down, but with the same amount, this will go up. So this down will cover, it goes up. So when you total this, it will go this line. So it will be a straight line. So in other words, total energy is always constant, and which is the sum of kinetic and potential. All right? With the sum of blue and green, that will be your red line. The question is the following: a spring. Okay, let me use almost similar to what I gave in your second exam. Alright?
Okay.
But I'm changing a little bit. A block of ice is on a frictionless table attached with a spring. Attached with a spring of a spring constant K. Give me a number. K is more or less what?
0.23.
What?
75.
75? Yeah, makes sense. Don't say zero. 75. Oh, by the way, 75 was last time when I gave, right? It was pretty much same process, same thing. Let me make it 150. Let me make it 200. Newton per meter. But I will go with you. Alright. Okay. A block of ice of mass what? Let me give me a number. Block of ice of mass, what was it?
5 grams.
5 kilograms?
Mass, I call it the mass 1, which is what?
1 kilogram?
42.
2 kilogram, okay. 2 kilogram,
Okay. It's alright.
it's okay. Make it a little bit different because I want to put something there.
69.
What? Oh my goodness.
5 kilogram.
5.
Alright. Okay. 5 kilogram. And is displaced. Displaced to, give me a distance. 0.7? Okay. Which is 70 centimeter. Right? I am going with you. Alright. 70 centimeter, 0.7. By the way, if it moves like this, this goes, squeezes and it goes here also, right? I'm not drawing on this side. Alright? Basically, this is going front and back.
Okay.
70 to minus 70, this is my origin. Alright? Now the question. Did you understand the question? So you can write in your own language. Language is yours. Alright? You can write it in Spanish or Chinese or Indian language. Right? Write down the ice block. Listen, the question here. The ice block of mass 5 kilogram or 5 kilogram mass of ice block is attached with the spring of spring constant 200 Newton per minute per 200 Newton per meter. Alright. The other end of the spring is attached to the vertical pole. The spring is displaced to the amplitude of 70 centimeter and is let it move front and back with a simple harmonic motion. Did you understand the question? Now another mass. Now by the time it is at the when it was moving, right? It was going front and back, and you put another mass there, another putty there, right? Putty of let's say I get 5, right? Makes it 2 kilogram putty. Alright? Or 3 kilogram putty. What you do is you drop it when that was right in the middle, you drop it there. Okay? So a 2 kilogram putty is dropped on the ice block. On the ice block, maybe the putty doesn't stick, right? Yeah, this is not ice block. This is another mass. Alright? A mass M1. Okay? So that the putty sticks there. Okay, if I say ice block, then but ice block was in your exam question, right? But now, well, the bottom side is ice block, let's say, but the top is a wooden block or something where the putty sticks. Anyway, you got the idea, isn't it? You got the idea. So on the mass M1, when it is at the center of oscillation. The question here is, you drop it when it is at the center. Now what happens is, look here. From those information, you have K, M, and A. What you have is, you have your K, which is 200 Newton per meter, you have your amplitude, which is, what is it? 0.7 meter, right? And you have your mass, m1, which is 5 kilogram. From this information, can you find the velocity? Can you find the velocity at the center? Can you find the velocity at the center?
Yeah.
So what will be your V1? What is it? Square root of what? What will be your velocity? Okay, I'll give you a clue. I'll give you a clue. At the center, your 1/2 mass times velocity square will be same as the potential energy at the end, right? Which is 1/2 kx square. Is that right? Which is at the end, which is a square. Is that right? So will that be enough? That will be enough, right? Because your V1 will be, what is it? V1 will be square root of k by m times a, right? K by m1 times a. So give me the number, calculate this. K use 200 and m1 use 5, and then take the square root and then multiply by a.
4.42.
4.42. Okay.
40. 43 if anything.
4.43 or 42?
Yeah.
How much did you get?
Because
43.
4.43.
Mm.
How many of you get 4.43? Okay, 1, 2, 3.
Because there is a 7 after
Four.
the 2.
Okay, I trust you. 4.42 meter per second.
Okay,
well,
well-
this is what? This is the velocity with which it is going front and back, right? Now what happens here is, when you drop that mass on top of, when you drop m2, there's another one, which is 30 is another one, something like this. This is m2, which is, what is it, 2 kilogram. When you drop this, the velocity will slow down, right? Isn't it? Because it's going back, when you drop it, velocity will slow down, obeying some relation. What happens there? If you drop another mass on top of one mass, which is already
The
moving, the
velocity
velocity
decreases.
decreases. But what is the relation? What's called? What's that? Called conservation of the velocity and mass. Momentum, yes. The conservation of momentum. Right? So basically, your M1 V1 will be same as M2 V2. But your M2 is what? M1 plus M2. This will be the total, because after you drop both of them, both the mass gets added. Your new mass will be M1 plus M2, and your new velocity will be V2, isn't it? So this is your new velocity. So your V2 will be M1 V1 by M1 plus M2. Can somebody quickly calculate this? M1 is what? 5 times V1 is what? Whatever it is. 4.42 divided by M1 plus M2 is what? What is it? 7. Okay, 7. Can you quickly calculate this for 3.16. Okay, so now what it means is your velocity decrease, right? Is that right? So the question now is, what's the question is now, when you drop this, what will be the new amplitude? Because of course when you drop it, now the velocity decreases, it will not reach to the same distance, 70 centimeters. Okay? Now the question is, what is the new amplitude? Alright, what is the A2? So how will you find now? Say it again? K square, right? Okay. Excuse me. So now, which is what? 1/2 mv squared, but now mass is what? m1 plus m2. Now they go together,
Yeah.
isn't it? 1/2 m1 plus m2 times v2 squared. This will be my new kinetic energy at the center, right? Will be same as 1/2 of k. My new A, k will not change because the spring is not changing there. Spring constant remains same, right? So can you find A2?
That's okay.
Can you find A2? This half will cancel. M1 plus M2 is what? 7, right? Your A2 will be, this is 7 times 3.16 squared divided by k is what? 200,
Square root.
and you take the square root. Yes.
0.59.
What is it?
0.59.
0.59. So your A2 equals to 0.59, which is 59 centimeters. Is that right? Right. So your, what happened there was your amplitude definitely decreased. Add one more. What is the new amplitude? What is the time period? How do you calculate the time period now? Time period is what? What was the formula for the time period? 2 pi, what is it?
Square root mass 4k.
2 pi,
M over k.
what is it?
2 pi square root of m over k.
This is T2, let's say. 2 pi square root of m. What is m? What is m?
It's a M1 plus.
m1 plus m2, right?
Yeah.
Over, what is k?
So, about 1.
Oops. K is same thing. Can you quickly calculate T2? 7 by 200, which is
1.18.
1.18 second. Is that the time period?
Yes.
Did everyone get the same number?
Yes.
Now, another question, the blue question. Another question, the blue question. What happens? What happens if you drop the putty when the mass m1 was at the extreme point, not at the center, but extreme point. Now the question is, look at the beauty here. The beauty here. If you drop this mass, the putty, when it is at the center, that was not a problem, right? Or that was this case, right? Your amplitude decreased and you have a new time period, right? But what happens means what will be the amplitude if you drop the putty when this was here?
So it's not
You
going
drop
to-
it here.
Oh,
Now this is oscillating here. Now you are waiting putty right here. When it comes there, and then I'll drop. All right, not in the middle. Okay. Now what happens when you drop it there? Now what happens? Does your amplitude change?
Is this it?
No, because you are dropping there, isn't it? So it goes there and comes back there. So your amplitude doesn't change. When you add the mass at the extreme point, your potential energy, which is Ka square, isn't it? Remains Ka square. K has to do with the only amplitude. So this will be same. Isn't it?
I mean, the potential.
Because it doesn't depend on mass, your potential energy. But your kinetic energy depends on mass. Are you following? So what happens here is, what it means is, you will have a new velocity at the center. It will not be 4.42. Are you following?
Yeah.
In this case, okay, you got the answer, right? Okay, find the velocity at the center. This one.
Professor, what is the stream point?
Say it again.
The extreme point.
Extreme point means the end.
So,
This is the extreme point. the maximum displacement.
So in this case, it's gonna be on M1 plus M2 this one
Say it again.
to get the velocity.
What is it?
To get the velocity.
To get the velocity? What?
So it's gonna be the same formula. But
Yes.
but you're gonna put the other max
Yeah, you use the same thing. But in place of m now, you have 2m.
M1 plus M2.
m1 plus m2.
Yeah, that's right.
Your this guy will be same. This one will be m1 plus m2.
Yeah, that's what I'm saying.
Right? Did you understand?
Yeah.
Did you understand? So find this. Find the velocity at the center. Can you do this part? The last one. All you do is use this. Your mass will be m1 plus m2, and you will get the new velocity. Because your k is same thing, a will be same thing, only your velocity will be changed. So what does it mean? What does it mean? Of course, the velocity will be small because this mass will be big. This is same, isn't it? Your velocity will go down. So what it means is it reaches there, but since the mass is more, so it goes like slow. All right?
Mm-hmm.
But it's gonna be the same.
Makes sense?
Yeah.
Velocity goes slow.
The same person.
Okay, so if you have further question, let me know. If not, I'll see you next week. Happy Thanksgiving.
With this.
Thank you.